This week, we're resharing one of our favorite episodes of the Single Tracks podcast. If you've already heard this one, don't worry, because we'll be back next week with an all-new show. Professional mountain biker Adam Craig says it's one of the top 3 places in the universe he's ridden. Where is this magical mountain biking nirvana? It's none other than Brevard, North Carolina, home to Pisgah National Forest and DuPont Recreational Forest. The area boasts over 300 miles of peerless single track, not to mention hundreds of miles of gravel roads, creating a near endless array of routes, terrains, and challenges to explore. 4 vibrant bike shops will get you sorted, whether you need gear, service, or a top-notch rental. Top it off with an array of craft breweries, cafes, and gathering spots that have earned Brevard the title as one of the best small towns in America in 2021. It all adds up to a premier mountain biking destination you'll want to experience for yourself. Find out more at explorebrevard.com. Hey everybody, welcome to the Single Tracks podcast. My name is Jeff, and today my guest is Joe McEwan. Joe is a career aerospace engineer and carbon composites expert who founded Starling Cycles in 2014. The brand's bikes are developed, engineered, and handmade for the demands of UK trails, and the bikes have been well received among both the media and athletes. Thanks for joining us, Joe.
Yeah, hello everyone.
So tell us, how did you get into mountain biking?
I think when I grew up, my house was opposite a bit of woodland. So my childhood was spent bombing around the woods on my bike, various bikes, BMXs and road bikes, but not really mountain biking as it was. So I rode bikes in the woods, but it wasn't until I'd actually then had a big period playing golf until my mid-20s. Then, so I was quite a good golfer for a while, and then got fed up of that and thought I needed to get a bit fitter. So I thought, right, I'll start riding my bike around the woods in Bristol, and then just kind of got hooked into it and bought my first mountain bike, and then just started riding more and more in Bristol and loving it more and more. And then it's got more, it's become the thing I do.
Yeah, that's funny. I always joke that mountain biking is the new golf. And I didn't actually know that people did that people like transition from golf to mountain biking. But that's awesome that you did.
Yeah.
Well, so tell me, what first piqued your interest in building steel bikes? You know, looking at your resume, it kind of seems like an unlikely choice for someone who's a carbon composites expert. So why steel? Why not carbon?
I think I tried to get some projects as part of my job. So I was working at a research facility in Bristol. And I was trying to convince my boss to let me build a carbon bike as a project, as a kind of learning for us all. But they just weren't interested. It was too much of a distraction from the day job. So I thought I still want to make a bike. I'm an engineer, so I always make the things that I do. So when I played golf, I actually made a few golf clubs. I made a few golf clubs. Before that, I was skateboarded for a lot, and I made a couple of skateboard decks. So it's always something I've done is made bits for the hobbies I'm interested in. And the easiest way to get into making bikes is to go on a frame building course. So all the frame building courses tend to be steel because that's the easiest thing to start with. But I'd always ridden steel bikes as well. So I've always had a steel hardtail. That's something I've always had. And my first proper mountain bike was a steel hardtail. I had a few steel. So I suppose when I started doing this, there weren't really that many steel enduro bikes or trail bikes. They just didn't exist. Kotick were kind of doing it. But there were a couple of companies doing steel downhill bikes. I had an SWD, which is an American company, doing really small scale steel mountain bikes. So I bought downhill bikes. So I actually bought one of them off Pink Bike. And then I bought a Doberman Stella, which was a Canadian brand, I think, doing downhill bikes. And I bought one of their steel downhill bikes. So I just felt I loved the feeling of the steel downhill bikes. They just felt damp. They felt great. So it was the obvious thing to make a bike was to start making steel because that's the easiest thing to get into. But I've also always been a lover of steel bikes, so it just made sense. Carbon is very difficult to do in your shed, whereas steel's a lot more accessible.
Right. Have you tried building bikes with other materials like titanium I guess aluminum, that's a totally different game, but.
Yeah, I suppose in terms of welding, the only welding I can do is brazing. So that's the only skills I've got. We've now got people in the workshop who can TIG, so we could potentially do, and he's done a bit of titanium work, he's done a bit of stainless work. He's done aluminium, but we haven't got the equipment to do that. But yeah, we're looking at other materials. We're always trying different stuff out. But steel is good. Nothing wrong with steel, really.
Yeah, yeah. Well, you mentioned the ride feel and
Yeah,
how, it's really good for all types of bikes, from, people think of hardtails first, but obviously, steel's used for all kinds of bikes, from trail to enduro to
yeah.
downhill. And a lot of people say that, they like steel because it absorbs sort of the trail vibration better than other materials. I want to know, is that true? Like, can the average rider really feel a difference between steel and, say, another material like aluminum or titanium?
I, I, I think what's going on is it's because steel is stronger and it's heavier.
Hmm.
You can make it with smaller diameter tubes. So
Okay.
I constantly get this thing on my bikes. If I post up an image, somebody comes back and says, "Look at the seat stays. They're so skinny, it's going to snap." And I've never had a seat stay snap on a bike. They just don't snap. It's a
Yeah.
very, very strong material. So because it's strong, you end up with small diameter tubes, and those small diameter tubes are more flexible than larger diameter tubes. And
Okay.
it's kind of it's a cube term, or it's a squared term, the stiffness of it. Aluminium, carbon fiber, lighter materials, you can get away with bigger diameter tubes. And there's always this belief that stiffer is better. So
Hmm.
automatically they go to the bigger diameter tubes because it gives a
Hmm.
stiffer structure for the same weight. So I think it's not because of the materials themselves, it's because of the way you use the materials that results in the
Mm.
compliance, that results in the so
Yeah.
typically steel frames, thin tubes, bit more flexible, bit more give in it, aluminium, carbon, bigger tubes, bit more stiffness. But there's
Hmm.
there's also some other behaviours that I haven't quite got my head around. So hysteresis, which is kind of how materials give back their energy.
Hmm.
So I think I don't know. Aluminium fatigues. The reason it fatigues is because as you bend it and you let go, some of the energy is kind of I don't know absorbed. And the same with
Hmm.
carbon fiber. It's got lots of fibers. As you bend it, it sort of damps
Hmm.
out the so you lose a bit of energy in the bending of steel and aluminium. Or sorry, aluminium and carbon fiber as you bend it back.
Okay.
Whereas steel gives all its energy back,
Hmm.
or much higher proportion of its energy back, which is the reason you have steel springs. You don't have
Hmm.
aluminium or
Yeah.
carbon springs.
Right.
So that's what gives steel a little bit of zing. I think that as you push into it, all the energy comes back out, and it sort of gives you a bit of zing, a bit of life, a bit of feeling about it.
Right.
Um,
Yeah.
and then I'll keep going. Some other things as well. The uh, the small diameter tubes acoustically are kind of better. If you've got a big
Hmm.
tube, it can make all the noises, all the rattles in the frame louder. It makes it's like a sound box. It's like a guitar sound
Yeah.
box. It
It's
makes
like an
everything.
aluminum baseball bat. You think about
Yeah,
that, like when you hit a ball with that, man, it's a very distinct sound. And you do
yeah,
hear that on the trail, rocks pinging off of the bike
yeah,
and
yeah, yeah.
all sorts of things.
I've never hit a baseball bat, but I use a golf analogy, which is when I played golf. When I played golf, clubs had tiny little heads. Now everything's
Hmm.
massive, and the noise they make is awful. It just sounds like someone's
Right.
smashing some kind of. So I think that acoustic element contributes a lot to the ride feeling as well. If your bike sounds
Hmm.
silent, if it sounds, if you're not hearing these awful noises, you feel more confident and you sort of believe in it a bit more. So
Hmm.
there's
Yeah.
lots of aspects why steel has a bit of life or has that perception that it has some life to the ride compared to other materials.
Yeah, that's awesome. I'm gonna have to make a mental note of that too, like thinking about sound in terms of ride feel, I mean,
Yeah.
we review bikes and products all the time and we talk about ride feel, but sound, I guess, is something that I never really
Mm.
associated with that. But you're right, like that gives the product a feel. I mean, we may not be
Yeah.
talking about like sensory touch, but we're talking about just sort of the overall, like, what do you think about it? What do you feel about
Mm.
the product? And that's really interesting.
So if you've ridden a bike that's absolutely silent and then it starts developing a rattle, you almost lose confidence in it. That
It's true.
silence is so important to allow you to
Yeah.
concentrate as well. And it's a mental sport, isn't it? Cycling, really.
Hmm.
However good
Yeah.
our bikes are, we only go as fast as our brain lets us go. So everything
Right.
to give us confidence in the bike is important.
That's super interesting. Well, do you think as it's applied to mountain bikes and specifically when you get into like the longer travel bikes, is the material as noticeable? I mean, obviously you're going to have fat tires and suspension
Yeah.
and other things that are going to play into that. And can you still feel that difference between steel and another material?
Yeah, I think you can. The silence, we just talked about that, so
Hmm.
that's an obvious one. But so I talk a lot about when your bike's going in a straight line and the suspension is acting in the plane of the bike, then you want the bike to be stiff so the suspension works properly. But it's not the tube diameters that dictate that. It's the overall depth of the frame. So the frame is, I don't know, 12 inches between top tube and down tube. That's what gives the whole frame its bending stiffness vertically. Um, so in that sort of direction, you want the bike to be stiff. But then when you lean the bike over, the bike is bending sideways. So if you put the bike at a 45-degree lean, only
Hmm.
half of the suspension force, or only half of the bump forces, sorry, are acting through the suspension. The rest is
Okay.
acting to bend the bike sideways. So if you've got a
Hmm.
massively stiff bike, it means the bike can't bend. But as you go around corners, it can move in the plane of the suspension, but not in the other plane.
Hmm.
Whereas if you have
Hmm.
a bike which has got a bit of give and a bit of movement to it, it's almost acting like a sideways suspension.
Hmm.
So the more you lean the
Interesting.
bike over, the more you want the bike to have that suspension. And somewhere in my crazy head, I've got a design for a bike with sideways suspension. like, like it
Hmm.
bends in both planes.
Yeah.
So
Yeah.
this people saying, oh, steel's rubbish because it's got compliance. So therefore your suspension doesn't work. It's rubbish. It's absolute rubbish. The steel
Hmm.
frame in its whole is plenty stiff enough, but you've got
Yeah.
this added movement going sideways. But you're right about the thing. Big fat tires do they dominate? I don't know. I've never done that equation, but I think when you start looking at deflection in wheels is quite important. Tires is
Hmm.
important. The frame is important. All of these components add up to the whole. Yeah, it'd be interesting to know what those components are. What the contributions of those different things are. But
Yeah.
I definitely know any reviews that have been done on my bike always talk about grip in corners, and I know
Hmm.
grip in off camber sections. That's always something that comes back, and
Yeah.
it just feels like it grips.
Yeah. Well, I mean, I guess at the extreme end of that, though, I mean, like you said, steel is plenty stiff. But say you're like a cross country rider or somebody who's more interested in like pedal efficiency, is steel gonna be maybe not as good a choice for that rider, or
I
um,
this this
is it
this
good for
is
that too?
this is this there's lots of science in mountain biking, which is intuitively you think, right, it needs to be as stiff as possible so that I can transmit all my pedal forces.
Hmm.
But if you take a step back and look at what's actually going on, the science sort of falls apart. So this is an example of the stiffness. If the bike is stiff enough that as you push on the pedals, you can generate the full leg force that you want,
Hmm.
then it's stiff enough. Making it any
Okay.
stiffer doesn't put any more forces through. If
Hmm.
if the if the pedaling forces cause the frame to distort a little bit, but you still can put full force in, the frame has to spring back. It doesn't
Hmm.
lose energy unless it's losing heat energy. So unless your bike is warming up, you're not losing energy. So
Right.
there was actually, I think it was the Bicycle Academy in the UK, like a frame building centre in the UK. Somebody did a little study there where they looked at a very, very flexible road bike, and they
Hmm.
looked at, as you pressed on the pedals, it did cause the frame to distort or bend
Hmm.
sideways, but the force
Right.
coming out the rear wheel was exactly the same compared
Hmm.
to a stiff bike. So
Interesting.
it's this, and yeah, another way of thinking about it is if say you're pushing on a floor, on a wooden floor, you
Hmm.
can push as hard as you want. If you push
Right.
with your foot on a sponge floor, the sponge moves out of the way. You can't generate the hard force. If you
Hmm.
push on a solid steel floor, you probably generate the same force as the wooden floor.
Right.
So, do you need a bike that's made of wood or a bike that's made out of the solid steel? You just need it to be stiff enough.
Yeah.
You don't need it to be very stiff.
Yeah. Interesting. Well, another thing that I'm curious about is beyond the material. how does the tube shape and even like the bracing within the structure affect the ride feel? I mean, it seems like if you add extra bracing in certain places, are you gonna stiffen up the frame and lose some of those qualities that you want from steel, or how do those sort of interact?
Um, so I think we kind of answered that saying that in the vertical plane, so the sort of depth of the frame, that's what
Hmm.
gives you vertical kind of suspension stiffness. Adding in braces and
Okay.
stuff there, generally you're doing it because for strength,
Hmm.
because you've got some kind of weak point, but that won't affect the overall stiffness of the frame.
Okay.
And that then applies to the tubes as well. So if you've got oval tubes, it makes
Hmm.
no difference to the overall vertical stiffness of the bike because it's just the distance from the neutral axis. So I'll start turning in giving a load of engineering examples in a minute, but
Yeah.
it doesn't affect the overall frame stiffness.
Okay.
Generally, why you've done things like change, tube profiles, I don't think it matters that much. I think even sideways, bending the frame sideways, it's just an oval will have the same sideways bending stiffness as a round if it's the same width. So making
Hmm.
it a little bit wider, but it's small beer, it's small changes. Tube
Hmm.
profiles are for aesthetics, I think.
Oh,
Braces and any
interesting.
kind of strength, anything like that is for strengthening. It's just to stop it breaking.
Yeah, interesting. Well, your current frame builds, most of them, or maybe all of them, rely heavily on Reynolds tubing. So
Yeah.
why do you choose Reynolds over tube stock from maybe other suppliers?
Um, Initially, I actually started using True Temper tubing, which I got from America. And the reason I did that was they had BMX tube sets that were actually in
Hmm.
quite long lengths, and they had tubing that worked for me.
Okay.
But True Temper went bust, I think, or they didn't go bust, but they stopped producing bike tubes.
Hmm.
And when I first started off Reynolds, it was quite tricky to get small quantities out of them.
Hmm.
They didn't. I think they're much better now. They're much better at doing that now.
Yeah.
Other brands, Columbus, Dedici, the Italian one, really only cater for road bikes. They just don't
Hmm.
do
Interesting.
they don't do tubes that are strong enough or thick enough walls for mountain
Hmm.
bikes. They're just not strong enough. So
Yeah.
I think Reynolds were kind of similar. And as I started producing more and more bikes, they've started producing me custom tube sets, and they're
Oh,
really good
cool.
at doing that. So they're very easy to work with. They very happily try different things out, and they've
Hmm.
been really supportive to me and really helpful. And the quality of their material, like the 853, the treated 853, is the strongest steel, sort of carbon steel tube set out there, I think, at the moment.
Hmm.
Um, it's good quality. So yeah, they're very supportive. It's local. We know where their steel comes from. There's sort of got a bit of traceability, which is good.
Mm-hmm. Yeah. Well, you mentioned that you're able to get some custom tube sets from Reynolds. What does that mean? Like, what are you customizing? Is it the length? Like, do the tubes come kind of pre-sized to what you need for different parts of the bike, or is it profiles, or both, or what is it?
It's kind of thicknesses. So um, yeah, I think my down tube is thicker towards where the main pivot is, and it's got a slightly longer butt so that it butts up nicely against where the main pivot is. So I've got more
Hmm.
material there. We've increased the wall thickness in the center a little bit, and then I think it's not one of their fancy DZB, which is triple butted, because we just don't need that.
Hmm.
Um, the top tube's pretty standard. The seat tube is a custom bent seat tube for me,
Hmm.
so it's got the right bend and shape in it. So really,
Okay.
it's mostly changing the butt profile, thicknesses. Yeah, they do that one bent tube for me.
Yeah. Yeah. So I imagine, I mean, hearing you say that, I imagine you're not getting like a 8 foot long steel tube in and you're like chopping it up for the bikes. I mean, if it's got a
No,
bend in a specific place,
yeah,
or it's, wall thicknesses vary in the center or towards the
yeah, yeah,
ends, you got to have them all sort of pre-sized. So is that how they
yeah,
come into the shop? They're already like
yeah,
right
yeah. So
size for the frames you need.
they come in. I think they're 850 long, something like that, and the butts are in the right position. So they're thicker at the bottom and the top, or one end and the
Hmm.
other, and then thin in the middle. And the
Okay.
butts are positioned so that all my sizes of frames, from small to extra large, could be used on that one down tube. I
Okay.
think top tubes, we actually use a couple of different lengths of top tube with different butts. Seat
Hmm.
tubes, we use two different lengths with butts in different places and like swages in different places. So, but yeah, they turn up in the workshop and we do minimal kind of chopping off at the ends. Yeah,
Hmm. Yeah, interesting.
not much waste.
Yeah, I'm curious. Like, what is the cost of tubing? Like a top tube? How much do you pay
Oh,
for a top tube?
thousands of pounds.
Thousands of dollars. Wow.
But I've just given them about £15,000 for tubes, so
Whoa.
they're surprisingly expensive.
Yeah.
Um, like I think my down tubes are about £40, £30 each,
Oh, wow. Yeah.
so
Yeah. I
they're
mean,
not cheap.
yeah, I'm sure it all adds up, but I don't know. I was thinking that one tube would be a few bucks, but
No, no,
that's
no, no.
that's a lot. Yeah.
It's
Interesting.
very high quality material. It goes through a lot of processing.
Hmm.
Yeah, there's a lot of effort. There's a lot of steps going. I think there's quite a good video on the Reynolds website where they show all the steps that they
Hmm.
go through to produce a tube, and it's like 50 steps for one tube just to.
Wow.
And what
Yeah.
Reynolds don't actually produce the tubes; they buy round stock from a supplier in Germany
Hmm.
of the particular tubing, and they all they do is butt it and profile it and heat treat
Oh,
it.
I see.
So
Yeah.
it's not Reynolds doesn't have a foundry in it producing tubes. They are the factory that turns standard round tubes into
Hmm.
final heat treated bicycle tubes.
Yeah, interesting. A lot of steps there that I
Yeah.
guess I guess I had never considered, and yeah, I'm sure some of our listeners find that interesting as well. So, are there certain design considerations that are unique to steel full suspension frames versus doing hardtails?
Um, yeah, I suppose. Yeah, I've only really ever made full suspension frames. We have got a
Interesting.
hardtail coming out soon. We've done a couple of fancy commuter bikes. That was just a
Mhm.
bit of a design, but they never really sold. So
Hmm.
we've got a hardtail coming soon, but a steel full suspension bike. I suppose your main design consideration is how you're going to manufacture it, because
Mhm.
steel is expensive to get machined compared to aluminium.
Right.
Um, you've generally got straight tubes. To bend tubes is quite tricky. How are you actually going to make this thing, and what processes are you going to use to make it? And trying to produce it in a way that keeps costs down. So I quite regularly I'll get sent a CAD model by some excitable young kid who's drawn up a bike, and they say, "Can you make me this bike?" And I go, "I can make you that bike, but
Mhm.
that machining is going to cost you £300, and that bit that you've got there you can't make, you can't fabricate that, you can't." So I
Yeah.
think carbon lends itself to somebody drawing it up in 3D CAD and making lots of
Mhm.
nice swoopy shapes and getting rid of any sharp angles, and then you can design the tooling around it and produce a carbon bike. Aluminium,
Mhm.
you're much more open to machining complex shapes, and you can create a whole area for your main pivot and your bottom bracket and all your linkages and stuff, and you can create those more complex shapes.
Mhm.
Steel, because it's hard to machine, because it's heavy as well. You don't want to use a lot of material, although it's strong.
Mm.
Um, you can't machine things too thin because they start falling over. So there's sort of a minimum machining thickness. So inherently, it adds
Right.
a little bit of weight to it. So you've got to keep things simple. You've got to keep things. I suppose I try to make it elegant would be the word I would use. So keep it simple,
Mm.
keep it elegant, and then that lends to a bike that's efficient and lightweight, and is a nice looking bike. So it's
Right.
it's it's the manufacturing really that dictates what they look like. And I see lots of people trying to do complex steel bikes, and they're okay as
Mhm.
one-offs, but doing more than one or two of them is going to be trouble. It's going to cost you money. It's not going to be a good
Hmm.
solution.
Yeah, interesting. Well, and I imagine too with a full suspension, maybe one difference is, I mean, you're essentially creating the front and the rear triangle separately, I guess.
Yeah,
Like
yeah,
you weld them up separately, and then I mean, you hope that they fit together in the end, right?
yeah, yeah. We actually get our swing arms made in Taiwan. So initially, I think the first maybe 100 frames we were making all the swing arms in the UK, and the swing arms are
Mm.
quite hard, um, and they're standard sizes, so it lends itself to bigger batch production.
Okay.
So a few years ago, I did a batch of 100 frames that were fully Taiwanese made, but that
Hmm.
added complications that I had to plan what sizes I need. I could only do
Right.
one model. Painting was more tricky. So the front triangle that now we do we do 8 or 9 different front triangles for the 3 different bikes, or the 3 different main bikes, and all the different
Mhm.
sizes. So it's quite a large number, but we can just make them to demand. Whereas the swing arms,
Right.
we only have 2 swing arms. We have a swoop and a murmur, and then the twist, that's the murmur. The mullet bike uses the
Hmm.
27 swing arms, so we can have
Wow.
swing arms sat on the shelf, and then we make all the front triangles to order. Um, so that's sort of, yeah, that helps us. What was the question? I've got now.
Yeah, that answers the question. But speaking of swing arms, why is it that most steel bikes that we see, why are they single pivot designs? Why not something more, 4 bar or other designs like that?
I think for this reason, that if you it's weight inefficient to start machining parts. So generally, if you've
Mm.
got lots of linkages, so the steel bikes that are more multi pivots tend to have aluminium swing arms and aluminium linkages and stuff. So
Uh,
like a linkage rocker arm, if you made that out of steel, and even if you made it as weight efficient as possible, it would
mhm.
still be much heavier than an aluminium one. Whereas a bike, a nice simple bike front triangle, you can make relatively light with steel. It's when you start doing the machinings that it starts getting weight inefficient.
So yeah, it's mainly a weight consideration.
Although I should caveat all of that weight doesn't matter. Like the
Right.
weight of a bike just doesn't matter. Like
Right.
it does to a certain degree. If you bolted 10 kilograms to your bike, it would matter. But whether you're riding with a full water bottle or an empty water bottle, you don't notice. And that's the sort of weight difference between a carbon bike and a steel bike. So people get a bit upset with it, and they get obsessed with it. But it doesn't matter. It's your size of your legs, and it's your wheels, how well your wheels spin, and how fast your tires roll, and how light your wheels are. Matter.
Yeah. Yeah. Interesting. Well, one of the questions that Jero was interested to learn about was about some of the design considerations that go into the head tube junction on your
Yeah.
bikes. And specifically, how do you make that stiff enough especially when you're looking at bikes with a really slack fork and, that head tube angle? It seems like there's a lot of forces that are involved there. And how do you keep that strong enough while also keeping the weight of the bike low?
I think it's less of an issue than you imagine. Like
Mm.
we've never had any head tube failures. So there's And you think BMXs take all kinds of abuse, and they're all
Mm.
steel, and they just have 2 tubes welded onto a thing. So there's generally though 2 ways to solve the problem. You either put a little doubler, which is a little small gusset, which essentially doubles the thickness of the tube where you think it's going to fail. And there's different arguments about where you put it. Some people, I think some of our bikes have got them, and you've got a doubler under the top tube and under the down tube, which takes
Okay.
the one of the forces after I should have to draw myself a
Right.
diagram and work out which force it is. Probably the compression
Yeah.
forces. The other school of thinking is on my bikes. I've got a gusset between the top tube and the down tube. And what you've done essentially is, if you imagine an I-beam has a top flange and a bottom flange, and then a web that joins it. And the
Hmm.
purpose of that web is where it transfers shear between top and bottom. So instead of having the top tube in both tension and compression and the bottom tube in both tension and compression, the web
Hmm.
between them means you put the top tube in tension, the bottom tube in compression, and you reduce the stresses. So the plate gusset that I've got on both sides almost increases the section locally so that you reduce the stresses. It increases the
Okay.
bending section. So
Yeah.
I actually did quite a bit of CAD work, or sort of FE work, looking at this, because people don't like those gussets, because occasionally people design those gussets really badly, where they just put a big
Mm.
triangle on. And if you just put a big triangle on, quite often it creates stress razors that then cause the tubes to fail at the end of the gusset. So if you look
Oh,
at my
wow.
gussets, they've got a nice long leg, which means the loads gradually track into the gusset, and then they can be
Okay.
transferred for, and then they gradually track their way out. So you've got to have intelligent design of that gusset. But if you
Yeah.
do it, it's quite a good solution. It's quite a good way of reducing the stresses.
Yeah. Yeah. I was going to ask about that, and you answered it, using finite element
Yeah,
analysis on the designs and figuring out like where are those stresses going to be concentrated.
yeah,
Um, I mean, I imagine too, though, you could maybe in the old days, would people just kind of look at where a bike fails and then say, oh, we need
yeah.
to reinforce that. But now it sounds like you're able to do that all.
Um, FE is my background is I was an aerospace stress engineer. I've done loads of FE. I've spent years
Mhm.
doing it. To me, it's a marketing tool. It's what you you produce a nice fancy picture that you can show to the managers and say, oh look,
Yeah.
we know what we've done. Everything
Yeah.
needs to be backed up with good engineering knowledge and hand calculations.
Hmm.
And an FE model is only as good as the information you put into it.
Uh,
And there's a lot of people who are taking their CAD models and applying nonsense loads to it, and then saying, "Oh, look, our bike is great, isn't it? We've done FE, we've optimized it." It's a good engineer can tell you where something will break, and that is much more important than FE.
yeah.
There's so many
Interesting.
risks of getting it wrong. So yeah,
Yeah.
the if it doesn't look right, that's almost more important. If it doesn't look right, it probably isn't right. And FE is going to tell you isn't going to tell you anything different really. It's
Right. Right.
where we used it was in a specific location where we had a problem that we could idealize very simply and understand the
Hmm.
behavior. So we took it out as a very simple case. But if we just run the whole bike into FE, you would gain nothing from it. It would be
Right.
good for marketing, good for your press release, but that's about
Yeah.
it.
Yeah. Well, you bring up a really good point about sort of the data that you load in and how you're actually looking at the bike. I studied structural engineering in school, and um, this was though looking at things like bridges or buildings, and it's like
Yeah,
that's a static thing.
yeah,
Whereas a bike, I imagine, is really complicated because of just all the different positions that a bike could be
yeah,
in and the
yeah.
different ways that you're loading it. And I'm wondering, with your experience in the aircraft industry, I mean, which is harder, like to analyze? Is it an aircraft wing, or is it a bike? I mean, which one of those is like more complicated in terms of
The
the forces at play?
Yeah, the big issue is with the forces. It's on an aeroplane, we were given a load set. You had a whole department dedicated to determining the loads on the aircraft.
Hmm.
And that's based on years and years of experience and refinement and testing. And then those top level aircraft loads, you kind of follow down through the various components, and there's processes
Hmm.
and various levels of FE to understand load transfer and all this stuff. So it's very, very well understood. And then once you know the forces acting on something, it's very
Hmm.
easy to analyze it, and you can do lots of different levels of analyzing. The loading on a bike is massively complicated because all the cases that are causing that loading tend to be strange dynamic cases. So crashes or big heavy landings or
Hmm.
or things that you don't even predict, and going around a corner and hitting a rock and then stamping on the pedal, or all these weird cases that you can't
Right.
predict, and
Yeah.
that data doesn't really exist. I'm sure the big companies have got pretty good loading data,
Hmm.
um, but because there's so many unknowns and because it's so dominated by an aircraft, you've got the engines and you've got the air pressures, and it's all pretty well understood. The
Hmm.
bike loading is dominated by the rider, who is moving all over the place and he's changing position all the time. So
Right.
and people ride in different ways. So
Hmm.
how do you determine? So I would every company, you can do CEN testing, which sort of says the bike is the CEN testing basically rides it into a wall and does a sort of a bit of a dodgy drop. And
Yeah.
there's a few other companies now who have developed some better testing. There's a company in Germany called EFBE who have developed higher level testing that that they've sort of proved with more sort of empirical data. Um, but yeah, even then, you're still relying on proper rider input and riders, sessioning it. I'm quite lucky. I've got one of my riders, Reese, who's Boosted Bryn, he's called. And not
Hmm.
only is he an amazing rider and he just hucks off massive things, but he's also an absolutely useless mechanic. So he's the perfect bike tester, that he doesn't
Right.
look after his bike and
Yeah.
he rides it really hard. So we know if it survives him, we're pretty good. And, so
Yeah.
yeah,
Yeah.
it's that loading thing is so difficult to understand. And even when they start loading up bicycles with lots of sensors and stuff, you're only understanding sort of the basic accelerations on the bike. You probably don't
Yeah.
understand how the geometry is changing. So
Right.
it's a much more complex loading situation than there is on an aeroplane.
Yeah, interesting. I always find it fascinating too, like the connection between the aerospace industry and bikes. And I mean, I think even from the early days, right? The Wright brothers, they owned a bike shop, as far as
Right,
I
okay,
know.
I didn't know that. Okay,
Yeah.
okay. What you find is, I don't know. Most mountain bikers seem to come from some kind of engineering background, or they're tinkerers. They like the whole having a bike that needs fiddling with is something they enjoy. Whereas road
Yeah.
bikers tend to be. I don't know many mountain bikers who are doctors or lawyers. I know lots and lots of mountain bikers who are engineers or
Yeah. Interesting.
carpenters or joiners, or they're.
Yeah. Yeah.
So I think go.
It's such an interesting sort of technical challenge. I mean, if we think
Yeah.
about bikes, I mean, they have to be light, but they also have to perform. And,
Mm.
same with airplanes, right? I mean, you got to make them as light as possible, but you need them to be as strong as possible.
Yeah. Yeah. Yeah.
And you don't even see that with cars necessarily, right? Like
No.
there's not always a big push. I mean, maybe with electrics now, but, there hasn't traditionally been a big push to like, we really have to get this thing right and
Mm.
use the right materials and all that to really optimize it. So
Yeah, I think cars are fundamentally designed for manufacture, aren't they? Everything is about manufacturing, and you
mm,
could save a few grams, but nobody cares. It has to be able to. You have to be able to produce 10,000 of them in an hour, and it's
right.
crazy. But bikes do get like that, and I think I'll be a bit cynical here about carbon bikes. I think the reason why there's so many carbon bikes is there's a perceived they are the material in itself is if used properly is a lighter weight is for a given strength, or is stronger for a
Hmm.
given weight, so it's got a higher specific strength. But when it's used in bicycles, I think everything's massively overbuilt. And if you actually have a look
Mm.
at a lot of carbon frames, they're not that much lighter until you get
Yeah.
to the very, very top end road bikes, but then they cost huge
Mhm.
amounts of money.
Right.
What's good about, or what I think is good for manufacturers of carbon fiber is that it's unskilled manufacturing in assembling. Once you've spent all the money on tooling and a process,
Hmm.
you can get anybody just to shove the carbon fiber into a tool, follow a process, press go
Hmm.
at the end, cook it, it comes out.
Hmm.
So what you see is lots of the carbon bikes are manufactured in China, where labor rates are cheaper and labor is less skilled. All of
Hmm.
the welded bikes are made in Taiwan, where they're made by skilled welders who have got lots of
Uh-huh.
experience. And so for big Mister Bike manufacturer, it's almost the McDonald's of bikes carbon fiber. Once you've got the process right and you've got the process under control, and that is a difficult thing. I'm not taking anything away from that. It's a very easy way to produce lots of bikes at a perceived high value compared to aluminium or steel, where it's a high skilled job. You've got to pay higher wages, produce it in a
Hmm.
higher cost country.
Yeah.
Anyway, a bit of
Interesting.
controversy there.
Well, no, yeah, the way you describe it too, it sounds like it is maybe more akin to the auto manufacturing model, where you
Mm,
can sort of standardize it and use different labor inputs to get it
yeah,
done. And yeah, it's kind of a different way to go. Well, let's get back to sort of talking about how you design steel bikes. So, why do some bikes like uh, the Murmur Trail specifically, need a brace between the top tube and the seat tube?
so that actually isn't the Murmur Trail. That is just the
Oh,
XL bike. So it's nothing.
oh,
All
just the
it's
extra large. Okay,
Yeah, it's just that the image on the website of that Murmur Trail is of an XL. So what
okay.
on the XL bike, if you have the top tube moving up proportionally as it would with the other sizes, the bike
Hmm.
looks like a bit of a gate. So The XL actually has the top tube at the same position as the large bike, but then a
Okay,
longer seat tube. And because the seat tube's sticking out a bit further, you need a little brace to
I
support
see.
it. So
Yeah.
it's kind of driven by aesthetics. It just big frames just don't look that good. So they look a bit better if you get the angles looking nicer. If you drop that top
Yeah,
tube, it looks a bit neater.
interesting.
So
Yeah, so is that standover height then that's kind of dictating that you
um,
keep the top tube at the same position
no,
across those
it's
sizes?
aesthetics. It just doesn't
Hmm.
look as nice. People with long legs don't need top tube clearance.
Yeah,
They'd be fine with the top tube in the high position, but
right.
it just looks bad.
So another question I have is how you're able to dial in bottom bracket stiffness when building with steel. Again, this is a spot, I guess, where I don't know. I would imagine you could feel that more when you're pedaling because pedaling is kind of side to side, right? Like you're going to maybe potentially feel some of that twist in the frame. So, what can you do to dial in the bottom bracket stiffness there, or does it even matter?
I don't think it even matters. It goes
Hmm.
back to what we were saying before. Um, you still get all those forces out. So I don't think it matters. I've never even thought about it. It's never a comment I've had back is that my bikes feel flexible whilst pedaling. And
Hmm. Yeah.
yeah, I get it with I supply middleburn cranks with my bikes, which are UK manufactured, and they're these the most beautiful kind of aesthetic tactile things in the world, but people always look at them and go, oh, they're too skinny, they're bent, and they just don't.
Yeah.
It's back to this whole pseudoscience thing. Oh, it has to be as stiff as possible, we want everything as big as possible, and in
Right.
reality it doesn't matter. It really doesn't matter. So
Yeah.
it's just that we intuitively think, oh, stiffness, we need it to be stiff so it pedals better. We don't take that
Right.
step back and think about, does it actually matter?
Yeah. Well, I mean, you mentioned too, though, how aesthetics does drive some of the decisions,
Mm,
and it's not always about making it strong or strong enough. Sometimes it just has to look right to people,
yeah,
and I think with carbon too. I mean, you like you said, a lot of those bikes are overbuilt, and in that case, it's not like a look or anything that people are going for. It's really riders, for years just didn't trust it. I mean, they were
yeah,
afraid that like this, it looks like it's going to break. It's too light,
yeah, yeah.
it feels plasticky. But yeah, I mean, I guess in a lot of ways we're not really rational when it comes to our bikes, are we? Like we
Mm.
just kind of look
But
at them and we form a judgment.
that's I think that's actually really important, and I think aesthetics is really important because it kind of goes back to we our bikes are all way more capable than we are. Unless you're very top level, our bikes are massively capable.
Hmm.
What's the best run you've ever had? It's when you focus, isn't it? It's when you're absolutely in the zone. You get to the bottom and you're like, you almost don't know how it's happened, but you know you've zoomed down. So a lot of that is confidence in your bike. So if your bike looks good and you're standing there looking at it going, I like this, I'm going to go fast on this, that is really important. That is really
Yeah.
important to how well you ride. And whereas if you look at it and it's, all the angles look funny and you don't like the look of it, you're not going to have any confidence. You're not going to be willing to, push it into the corners and really drive it in. So it's really
Yeah.
important aesthetics. Yeah, it's key, I
Yeah.
think.
Yeah. Well, and I think part of the takeaway for me is to trust the bike designers, right? I mean, like
Yeah.
you've done the analysis and whether I think it looks like it's going to be strong or not,
Mm.
that's, maybe not that important. I mean, bikes do fail, but it's pretty rare. So I think, yeah, maybe we could all do better to just trust that the bike has been designed and to give it a ride and
Yeah.
see how it,
They,
it actually does
it's
feel.
it's not in the interest of bike companies to have bikes that break. It would be the end of the
Right.
company.
Right.
If failures are so highlighted these days, it's just you wouldn't have a company if your bikes didn't
Hmm.
last. The word gets around so quick, and
Yeah.
people do have quite a lot of warranty issues, but they tend to be non-catastrophic stuff, don't they? And they tend to be little pernickety things, and I think customers are quite accepting of that. But I
Yeah.
think yeah, and we have certification testing to ensure there aren't going to be big failures.
Yeah.
So I think, yeah, they're pretty good things.
Yeah. Well, with all the recent supply chain disruptions, I'm curious to know how that's affected your frame business. On the one hand, it seems like maybe you're in a good position because you kind of build frames, as the orders come in, sizing and that kind
Mm.
of thing. But on the other hand, I imagine it's hard to get supplies. So what's it like right now?
In terms of building frames, we're pretty good. We can get all the materials we need to build frames, so we can
Hmm.
do that. And in the past, we've sold typically a frame, maybe a shock, maybe the odd fork, a few odds build components, and we've
Hmm.
had good supply of parts. As time's gone on, because people can't buy components elsewhere,
Hmm.
people are requesting more and more full builds, and
Uh,
yeah, I'm really struggling. So we're pretty good. We've got shocks, we've got dropper posts, we've got wheels, we've got handlebars and stems and all the build kit parts.
mhm.
Brakes, we've got good supply of. Forks is really tricky. We're struggling to get hold of forks. Drivetrains is really hard. So
Oh,
I've
geez.
yeah. So those two parts we've and what it's meaning is I'm having to spend more money stocking up and building up my stock so that
Hmm.
I've got them. Whereas in the past, I could order much later, I could be more
Right.
flexible. But now I'm having to put in big orders for less range of parts just so I get them and that I've got them sat there. So it's really hard. It's the big peak we saw last year when everybody was buying bikes, and I think every bike
Hmm.
company went through it, is now turning into a lot of pain, a lot of
Right.
pain. And
Yeah.
there's other issues with so I say my swing arms come from Taiwan. There's been a bit of delay and slip there because of COVID and just demand. But the
Hmm.
shipping costs is absolutely mental now. So the cost
Oh, geez.
of getting a shipping container is it's gone up 5 or 6 times. And I know
Hmm.
I know some brands that I've been speaking to selling lower cost frames or lower cost bikes where the increase in the shipping is all of their profit. So they're
Oh,
basically
geez.
just filling warehouses in China and Taiwan with bikes that they can't afford to ship because they would make no money on them.
Oh, right.
So
Yeah.
it's really tricky.
Yeah, interesting. Well, I'm surprised too that a lot of companies in that specific position aren't raising their prices.
Yeah,
I mean, do you feel that from consumers that there would be a lot of pushback if you did have to raise your prices?
I think it's difficult. You don't want to do it.
Yeah.
So people don't want to do it. And I suppose there was I think about 6 months ago, everybody went through a price
Hmm.
increase. There's sort of a few companies did it, and then everybody followed suit. And I
Hmm.
think there is another one due, but nobody's been brave enough to do it yet. But as soon as one company puts their prices up, I think everyone will because the costs of everything are going up.
Yeah.
Everyone knows it for everything is going up. So
Yeah.
um,
Yeah.
yeah, we will
Well,
see
and I
it.
think it seems like bikes perhaps are more affected than other things, that we're used to buying in that, like you're saying, there's so many components that go into a bike build and you could have every part except for one and it's not a bike. And so
Yeah.
to get all of those lined up and to have all of them
Mm.
delivered and available, yeah, it seems like it's a nightmare and hopefully something that's going to be resolved soon.
Yeah, I don't think it's getting resolved. I don't think it's getting resolved soon, and I think it
Yeah.
is affecting. I think it's affecting everything. I know. Talking
Yeah.
about golf, somebody I was speaking to was saying they can't buy golf clubs at the moment because of supply
Hmm.
issues. It's affecting everything at the moment. Um, it's just we know about bikes, so we're just paying attention to bikes, I think.
Right, right.
But in
Interesting.
terms of in terms of when it's going to get resolved, I don't know. I think so. Shimano have got a new factory on that they're building, haven't they? But that's a couple of years away. So
Yeah.
you know, demand has gone up, supply has gone down. People are stockpiling. People are hanging on to bits. Like 12-speed chains. There's no 12-speed chains in the country. So
Oh, wow.
if 12-speed chains turn up, everyone's just going to buy loads of them because they'll
Right,
be worried about it. So everyone's just stockpiling stuff, which just adds to everything even more. So single
right. Oh
speed
my
bikes, I
goodness.
think.
Jeez. Yeah. That's hard to get your head around how
Yeah,
interwoven all of this is and how many
yeah.
different things need to get fixed to get things moving again. Well, one interesting component to a lot of people, alternative to the traditional drivetrain, is the gearbox. And Starling has a gearbox-driven model, the Spur, that we wrote about several weeks ago, and it was super popular with our readers. So I'm curious to know what you're hearing about from people who maybe bought the bike, and then other people who saw it and are just like, "Wow, this thing looks really interesting."
I suppose to begin with, nobody's bought it yet because we're just making the first batch. So that was
Oh, okay.
what we sent you was the press release for the
Mhm.
production batch. So we've got a couple of prototypes riding around. One that's been ridden around by someone in South Wales for a couple of years, and I've had one for 18 months.
Okay.
So they ride great, and we've had no issues with them. So it's a great product. But yeah, it'll be interesting to see how they're received by customers. So hopefully they'll go out towards the end of the year, and that'll be really interesting. But
Yeah.
it's yeah, it's a the gearbox is a great thing. A derailleur is a terrible thing on a bike, but they do work pretty well, and they have got better as time's gone on. Like
Mhm.
I don't know, 10 years ago they barely lasted 5 seconds, and they were constantly getting
Right.
knocked off, and they never worked quite properly. They are pretty good now, I've got to say, but
Mhm.
the benefits of the gearbox in that everything's a bit more robust. It's maintenance is zero pretty much. You change the oil once every 6 months. With bike design, I think it helps quite a lot. So with the Effigear system, you can have a sort of highish pivot. You can have a single speed chain with the same chain line, which means that runs a lot better. You've got rid of a whole load of mass at the rear wheel, so the suspension is absolutely amazing. It's so supple because
Mm.
the rear wheel is so light. So there's lots of other
Yeah.
knock-on benefits on top of just having the gearbox. But there
Mhm.
is a little bit of a negative that at the moment there is a little bit of drag in the system. So it's great, and as a sort of up and down bike, or slowly winching up the hills and plummeting down, or actually going up technical climbs, it's absolutely amazing because
Mhm.
the rear wheel is so light, it just grips. But you wouldn't
Yeah.
want it as a cross country bike. You wouldn't want it as a sort of bike to ride loads and loads of miles on. But maybe that'll come. Maybe it will develop. But I don't think there's any incentive for the big players to develop a gearbox really.
Yeah.
Not for a
Interesting.
while.
Yeah. So yeah, you think this is never going to be something that gets like really wide adoption. It's just an alternative for people who maybe value kind of what the gearbox offers over derailleur.
So I just think Mr. Shimano building his new factory, unless he's building his new factory to build gearboxes, which I
Hmm.
doubt because he would have approached, there's a massive amount of investment to change over your production. And I know they've done it with
Hmm.
e-bikes and stuff, but that's a bit more of a certain market. They've probably got more confidence
Right.
that so the gearboxes will probably only be adopted by mountain bikers and commuters
Hmm.
have got hub gears. They're not too fussed about it. So you could argue
Right.
it's a relatively small market compared to, I don't know. I'm not Mr. Shimano. I'm not Mr. SRAM. I don't know what's going through their heads, but
Yeah,
to me, it's a high risk, and they're unlikely
for
to they're
sure.
unlikely to accept that risk until they know there's definite benefits. And
Yeah. Yeah. I mean, it seems like there's always a lot of interest from
mm,
riders. And like I said, our readers especially were like, wow, gearbox. But then at the end of the day, it doesn't seem like people actually end up putting one on their bikes. And yeah, I'm
yeah,
just trying to figure out what the disconnect is. Is it just the novelty of it that people are interested in, or is it something that they're like waiting for some big improvement to see where like it finally makes sense, or they're able to get over that hump?
it'll be interesting to see when these bikes go out because I love mine, but I ride it, I don't know, 30% of the time, and
Hmm.
50% of the, well, I'll probably ride my single speed 30% of the time. That's brilliant. I ride my Murmur, which is my sort of trail bike, a third of the time, and I ride the
Hmm.
gearbox bike a third of the time. But if I know I'm going out for a 4 hour ride, 3 hour ride, I wouldn't take the gearbox bike. If I'm going for a couple of hours to ride some downhills and ride some technical stuff, I'll take the gearbox bike. So yeah, it's not. Everyone seems to want one bike that does it all. It's not. It's not that. It's just an extra bike
Okay.
to add to your arsenal, I suppose. But it'll be interesting to see what the feedback from customers is. And some people will love it. Some people will not get on with it.
Right.
So it's
Yeah.
it's yeah, it's tricky. It's tricky. Interesting, but yeah, it's
Yeah. Well, speaking of another interesting development, what are your thoughts on the rising popularity of mixed wheel bikes?
Yeah, yeah, mullets. It is. I've kind of, well, I've kind of convinced myself of the science of wheel size that
Mm.
there's no difference in people talk about bigger wheels have got better rollover. And if you actually look at a 29 compared to a 27
Mhm.
and you imagine like a 50 mil bump, 50 mil high bump, 2 inch high bump, um, where
Mhm.
it hits the wheel, there's negligible change in the angle it hits the wheel up. So when you start getting to bigger
Okay.
wheel lumps that are close to the axle, it does matter, but that's not rollover. That's something else you've got to pull up. So I don't think it affects rollover. Acceleration, it actually doesn't affect acceleration because although the bigger wheel is bigger, it's actually rotates slower because it's bigger and it rotates proportionally
Mhm.
slower. So the amount of spinning energy is actually the same between different size wheels. So there's no
Mm.
acceleration. The only difference is the wheel is bigger. So overall it weighs more. But that in terms of bike plus rider weight is tiny.
Mhm.
So that doesn't matter. Um, People say this ridiculous thing, oh, bigger tyres have got a bigger contact patch. And this is the
Mhm.
one that winds me up the most. Contact patch is only a function of the pressure in the tyre. So the
Right.
pressure times the area is the force that supports the rider's weight. So
Okay.
a 3 inch tyre with 20 psi has got exactly the same contact patch as a 1 inch tyre with 20 psi. It's got
Mhm.
nothing to do, and a 29 inch or a 27, it makes no difference to the contact patch. So
Yeah.
that one drives me mad because it's really simple science. But everyone goes, "Oh, fat tires have got a bigger contact patch." They haven't. It's just that a flat tire you can run at a lower pressure
Right.
because it's got more volume to it. So
Mhm.
that's what it is. It's a bit more suspension, so you don't whack the rims. But so
Yeah.
the thing I've kind of concluded about the wheels is the bigger wheels have got more gyroscopic stability. As the wheel is spinning, its tendency to stay in plane, to stay rotating in that same plane. That property is a function of the radius squared. So a bigger wheel, a 29, will be proportionally greater than a 27 and a half. So what it means
Mhm.
is as you're riding along, the wheel is sort of less likely to get knocked off line. And
Okay.
you can feel it when you ride a 29-inch bike. You have to put more effort into leaning the bike over. You can
Mhm.
feel like it needs more effort.
Yeah.
Um, but then once it's leant over, it's more stable and it sits there.
Mhm.
So 29s, the first thing I felt when I rode a 29 was I could do a two-wheel drift absolutely amazingly because it was just so stable in that two-wheel drift position. It just sat there.
Right.
But then
Mhm.
it's harder to move it around. So if you were the sort of person able to do a big whip off a jump, a 29 is going to be harder because it's more of that
Ah,
gyroscopic
right.
stability.
Mhm.
Um, so if you're the thing I try to say to people, if you're somebody who likes to hop and jump off, just continually changing line, always hopping over routes, always moving their bike around, always flicking it left to right. You don't
Mhm.
want a 29-inch bike. You want a smaller wheeled bike, and I suppose like a
Right.
BMX, which is really
Mhm.
manoeuvrable. The big wheel bikes aren't manoeuvrable, but they track and they carry speed, and they're imagine riding the bigger wheels into a rock garden. The wheel isn't going to get kicked offline, so it's carrying
Mhm.
more forward momentum. So that's the perceived rollover is that it doesn't
Mm.
get kicked offline; it just keeps going straight. So
Right.
if
Interesting.
you sort of follow that logic through, a mullet bike sort of makes sense that you've got the front wheel, which is the one that steers, and the one that tracks through, which is the big stable one, and then the rear
Mhm.
one, which can be moved around. It doesn't matter; it just follows. So, and
Mhm.
the smaller rear wheel allows shorter stays, which people seem to like for a bit of pop and a bit of maneuverability.
Mhm.
But to me, it's not it's not a golden ticket, a mullet bike. It's just the halfway point between a 29 and a 27. So
Yeah.
it doesn't. It's not that this is a 29 is 8 out of 10, or a 29 is 6 out of 10, and a 27 is 5 out of 10, and a mullet is 10 out of 10. It's just halfway between the two.
Right.
So
Yeah.
anyone saying it's magic or anything, I just don't believe it. It's just a little bit different. Some people,
Yeah.
the biggest benefit is probably people with short legs who rub their tire on a 29-inch bike on their bum
Mhm.
on a 29-inch bike. That's a definite positive. So I
Yeah.
and again, if you're somebody, yeah, it's a halfway house. We're we're we're
Right.
we're doing a we've got a hardtail coming soon, and that's going to be a mullet hardtail. And for a hardtail, it kind of makes sense that it allows us to have slightly shorter stays. And to me, the point of a hardtail is for fun. It's not for racing and for going fast. It's for
Mhm.
having fun on. So the mullet
Yeah.
kind of makes sense on that bike that you've got the shorter back end, but you've got the bigger wheel up front for a little bit of stability. But
Yeah. Yeah. Interesting. Well, is designing a bike like that more difficult, like in terms of the geometry and stuff, because it is using different wheel sizes and you have sort of different axle positions from
so
front to back?
so so all my bikes are actually designed so that the bottom bracket, main pivot, shock mount, seat tube, that whole central area is identical on all my bikes.
Mm,
So
mm,
the 29-inch bike, so the head tube is really the only thing that moves on the front. So for a bigger bike,
mhm.
the head tube moves forwards. For a longer fork or a 29 versus 27, the head tube moves up. So you just move in that
Mhm.
head tube position relative to everything else. The same
Yeah.
happens at the back. If you want to run a 27-inch wheel, you just need to drop the axle a little bit and move it in and make it a little bit shorter. So the only difference between my two swing arms is the axle position. So the 27 one is 19 mil lower than the 29-inch one, and it's 10 mil shorter.
Mhm.
So really, this
Yeah.
should be it's very very simple. But what's happened is a load of brands have decided, oh, mullet's the thing to be. The mullet is the golden ticket, and they've tried to bodge a mullet into their existing bikes. And because they
Mhm.
don't want to change their swing arm design or their swing arms aren't interchangeable, they've started fiddling with linkages, and because that's the cheap bit to change. And
Mhm.
what made me a bit of a rant here? What made me very angry was when mullets first appeared, and everyone said, "Oh, mullets are great because you've dropped your bottom bracket and you've made it lower and you've made it all slacker." And I was like, "No, that's a bad mullet. That's where you've basically cocked the geometry up to put the wrong size wheel in the
Right.
bike." Whereas
Yeah.
all my bikes are the geometry isn't compromised by different wheel sizes.
Mhm. Yeah.
And then one other point, I'll keep going. Did you see the video we did about the Telum?
I did not.
Watch search up. I think it's on YouTube or it's on so the Starling Telum, Tellum. So that was a
Mhm.
an April Fools we did where we essentially built a reverse mullet. So that's very simple for us to do. We took a swoop front triangle and a murmur rear triangle, and they all go
Mhm.
together. So we had 29-inch rear, 27 front, and my whole story was my logic that I explained before was totally wrong. I was just following the trends. What's better
Yeah.
is that your front wheel is really maneuverable and you can move it around and put it in different places. And then the
Mhm.
rear wheel just tracks through, doesn't it? The rear wheel, you don't put any input, it just follows through. And this
Right.
reverse mullet, which was an April Fool's Day, an April Fool's joke, actually rode really well. It was really nice to ride. So
Huh. Yeah.
I
Interesting.
think yeah, you can somewhere along the line apply some kind of logic to make anything seem good.
Right. Yeah. Yeah. It sounds like a believable story for
Yeah.
sure. Well, you mentioned the hardtail that's coming, and then yeah, you're working to get the new spur models out the door. What else is next for Starling Cycles? Are there any steel e-bikes in your future, perhaps?
Yeah, so we have a prototype steel e-bike. So there's a video on EMBN at the moment where Steve Jones is reviewing the bike, working with a new motor company, UK-based motor company called Freeflow. So we've got one prototype. Um, it's got quite a small battery in it, but that was just to do with the steel tubes we got. So we're working on a second prototype at the moment to get a
Right.
bigger battery in there. But it's
Yeah.
lovely. It's jack drive. So if you like my Stern, you've seen the downhill bike with the jack shaft. So like the left
Hmm.
hand drive cranks up to a shaft or anything. So it's the same as that. So high pivot, jack
Okay.
shaft, 170 travel. So that hopefully will be coming pretty soon. It was second prototype, and then we shouldn't. It's
Oh,
not
cool.
that far from production really. So yeah, steel air bike.
Yeah. Yeah. It seems like that would be really challenging. I mean, I guess that's why I'm surprised is that yeah, you don't have the tube shapes. Maybe that kind of limits where you can put batteries and things and the motor and all of that. I mean, I guess you can design around the motor, But
Yeah,
is the battery sort of more of the challenge?
the motor. So this free flow motor just sits in essentially an enlarged bottom bracket. So it's a 120 mil bottom bracket. So it's just a big
Hmm.
cylinder. But they've
Yeah.
now got a sort of clamshell type arrangement. But it's very simple to integrate that into bikes.
Hmm.
The battery, the first prototype, we were putting the battery inside the down tube, but once you start getting to large diameter steel tubes, the wall thickness goes up. So our
Mm.
steel down tube weighed about £3. It weighed an absolute ton, maybe
Oh,
more
wow.
than that. So
Yeah.
we're now going to a solution with an external battery, and then some kind of we're trying to design a structure around that to look nice. Potentially, sort of maybe a motorbike type chassis, or we're looking at kind of a carbon
Mm.
guard to protect it. And
Yeah.
the removable battery is quite good because it means you can either just put a spare in your pack, or you just where we ride, you just park at the bottom of
Right.
the hill and go up and down. So you just go to the bottom and slap a new battery in. So
Hmm.
it's looking quite good. It's quite exciting. And I think you've
Yeah.
got to do an e-bike. E-bikes are outselling other bikes. If I didn't have an
Yeah.
e-bike, there's a risk to the company, really.
Yeah. Yeah. Well, that's cool. Yeah. It's surprising, but yeah, fascinating that you're able to take steel and to do all these different things that,
Yeah,
maybe it seems like the bike industry moved past that a long time ago, right? Like they kind of decided that's old technology with
mm,
steel, but you and with Starling are able to show that it's super applicable and adaptable and
yeah.
works for all kinds of bikes. And that's really exciting.
I think I suppose I've been quite lucky that when I've started making bikes, um, steel used to be the material to make bikes from, and then aluminium came
Mhm.
along, and then carbon, and steel has sort of dropped off the back. But then people have started not liking carbon for various reasons. It's
Mhm.
not as tough. You get any bits bonded in fall out. If takes a big
Mhm.
dent, you lose any confidence in it. Environmentally, it's pretty disastrous as well. And
Right.
um, so I think steel is sort of making a bit of a comeback, and I've been lucky that I've appeared at the right time that people are starting to feel negatively about carbon, and steel has then had the opportunity to rise again, really. So,
Yeah.
I think if I tried to start Starling 10 years ago, nothing, would have failed terribly, but just timing's been
Yeah.
quite good.
Yeah. Fascinating. Well, Joe, thanks so much for taking the time to chat. I learned a ton about steel bikes and I'm really excited to see what else you guys have in store. So thank you.
Yeah, thank you. So I hope I haven't ranted too much. But
Well, you can find out more, see pictures of some of the bikes we're talking about, and connect with Joe at starlingcycles.com. That's all we've got this week. We'll talk to you again next week.